اوكي، السلام عليكم، صباح الخير اعزائي الطلبه، ارحب فيكم في اول يوم في هذه الماده. Just introduce myself and the course. Inshallah, start with the chapter 1. My name is Dr. Fadal Basri. Been teaching this course since I came from my PhD. I graduated from University of Bahrain a long time ago, as you are from the Department of Electrical Engineering, University of Bahrain. I did my master's also from University of Bahrain and also in electrical engineering. I finished my PhD from Canada in the area of also power system, specialized in the power system protection. So this is my specialty. I work as an engineer in electricity and water, Ministry of Electricity and Water, in Citra power plants, and then I joined the University of Bahrain. So my overall background. I wish, inshallah, this course is very important. I wish that you will benefit out of it during once you graduate. You'll see it's very important course within your fields. I don't know what's your expectation. This course requires, like others, it's need dedications. You need to give it a time. Learning is successful if you are consistent, consistent in learning by attending classes, by asking questions, by your participation, by summarizing things. Okay. Don't really do your part, even if it's not perfect. And don't rely on something ready and fast fix. Okay. And many students during these times, especially these times, relies on past year reports, or so they don't even write a report. So they graduate with having no skills on writing, or if they are in a group, they don't participate in it. And this is a problem. So you are solving your problem on submitting assignments or a piece of work, but you are deceiving yourself in this way. You are the bigger loser if you think you have succeeded in this way. Even if you have a report from past year, try to write it yourself. You can use it as a reference. You can refer to it, but you have to learn how to write. Okay, you have to learn. You need to learn how to practice, Shabab. Practice solving the problem yourself. Don't wait one day before the exam to prepare. It is a continuous process, daily schedule of revision and working. Let me share with you start with the course outline first. Okay, can you see this, Shabab?
Yeah, yes, Doctor.
Yes, Doctor. Now it appears.
Okay. Okay. So the textbook normally I am following, or at least I don't have one particular textbook that I'm using. So the textbook is Power System Relaying by Stanley. You can refer to any version, but if you get the latest version, is fine. And you can refer to predictive relaying by Blackburn. I'm using to also, but my notes is not taken from one specific reference. Sometimes I go to standards, sometimes take from textbooks, sometimes my own experience, sometimes from commercial products. Okay, so it's a collection of materials from different sources. Course outlines these are what is intended to be learned by the end of this course. So by this course, you'll be able to know, by the end of the course, you'll be able to know what's a protection system, and what's the building block of a protection system, what are the characteristics of a good protection system, some definitions related to the protection system. So this in the introduction chapter, inshallah. Then in the next chapter, we'll focus on instrument transformers, and you have two types of instrument transformers, current and voltage transformers. These are not same as power transformer that you have taken in machines course. It is a transformer dedicated for measurements and protection. So you will know how do you select properly a current transformer for the protection or measurement applications, such that this transformer will not get saturated during short circuits. The chapter 3, you'll be able to know the different type of protective relays. These are the hearts of the protection systems. We'll go from the electromechanical technology to static and latest numerical relays, how they are built, okay, and the principle of operations of these technologies. Then we'll follow start covering the first and oldest principle of protection, which is based on overcurrent. When current exceed a threshold, a limit, then we declare there is a force or there is an overcurrent condition, and a relay trips the protected equipments, okay, at a set time. We'll focus on this chapter. How do we set the current settings and at which you detect the faults, and the timing at which the relay trips the circuit breaker to disconnect the protected equipments or the faulty equipments. We'll focus on radial systems on this. So this is dedicated, and generally this is the type of protection we use to protect distribution systems, feeders. Then we'll focus on directional relays. How do you protect systems that have loop system or ring systems or barrel line systems? Okay, so we need directional relays. So how directional relay operates, how we select the directionality. Okay, so this is a dedicated chapter on this. Then following the differential, protection. This is a new, sorry, this is another principle of detecting force by comparing the currents entering and leaving components. So we call it differential. We take the difference between those currents and decide whether there is a fault inside this component or this equipment or not. And we will apply this principle to transformer protections, busbar protection, generator winding protections, or motor winding protections also. Later, we'll cover the distance protection principles. Distance protection normally used to protect transmission lines. However, these are based on measurements of the impedance of the line, and if the impedance of the line, of the measured impedance by this relay is smaller than the impedance of the line, force is declared inside the line. After that, I'll give you one application that covers different other protection principles that's based on thermal overload protections, on imbalance protections, on under voltage and over voltage protections. All of this in one applications. I'll show you in the chapter, inshallah. That's in chapter number 7 and 8, AC motor protection, which is here. And in chapter 9, we'll cover the circuit breakers, different types of circuit breakers, their principle of operations, and it's important, how do you select them, okay? So these are overall about each chapter, what we will be covering, okay? Also, the grading, there will be no quizzes here, but I don't know, there will be one midterm which will be on site I don't know, if the situation persisted like this, it might be online, but if it's opens, it will be on site at the university. So it carries 30%. Labs will have 2 reports, carries 10%, and this is a collaborative work. A group of students can work on one report. But even if more than one work in one report, the usual students, what they do, only one does the report and the other will add their names, okay? And this is not the collaborative work. Collaborative work that you collaborate in on writing the reports, on building the components of the report, participating. So some of you will do that parts, other parts. So before submissions, all of these students should read the report, and so that the report becomes better than a report that is done by one person. Projects, it has 20% mark, and it need to be submitted by the end of the probably mid of May. We'll start presentations, so it is submitted by May of 9th. This project focusing on this is an individual. Each of you will present a topic related to the protections and something new on power system protections. So I'll give you after the mid-semester break, I will give you what's the requirements to start working on this. And this is the grade distributions. Do you have any questions, Shabab?
واضح دكتور.
Okay. And this is the weekly breakdown, inshallah. I'll start today with the introduction chapter, and which will take me just this week, today and next lecture. I'll finish the introduction lecture. So you'll see here the topics distributions, including each chapter that I have mentioned. And this can be downloaded from the Blackboard information section. So in the information section, you have this file that you can download, and has all the course descriptions and grading systems. And the content you'll find in the content sections, you'll see the all the chapters here from chapter 1 to chapter 9. And each chapter has the PowerPoint presentations, lecture recording from the past semesters, okay? Additional information, sometimes you cannot find it in the slides, so you'll see it here, additional informations. Or sometimes you'll see some videos on CT testing, for example. Some have tutorials, okay? Tips, assignments you don't need. I have a previous assignment, but you don't need to submit them. I normally don't ask for assignments, but you need to practice. If there is any test, you will see them in the test sections, but now you'll not see any tests now. So all the tests, if it's online, it will be, you will see it in the test section. Okay, Shabab. So that's related to the course in general. So do you know, Shabab, what is the difference between a protection system and a control system? Any participant, Shabab? Is there any difference between a control system and a protection system? اوكي اكيد في فروق. اوكي والا سميناها الكورس control of power system. Okay, not the protection of power systems. So what is the difference? Anyone, it doesn't need to be correct. يعني, your participation is just anything that comes in your mind, we can discuss it, it's fine.
The protection for if there is any fault in the system, and the control, how does the system work?
Control how the system works, and the protection is?
If there is any fault in the system, it will protect the system from damage.
So it will protect the system from damage. Okay, can anyone add? Thank you, Amal. Anyone can add? Hassan, Habib, are you with us?
يس دكتور، واحد منهم يعتمد على الباور، يعني توزيع الباور بيكون يعني يعني اللي هو
يعني الكنترول انك شلون توزع الباور؟
ايه بيكون بطريقة سلسة، يعني البرودكشن بيكون على طريقة الباور بيمشي لك بسلاسة، الكنترول بيعتمد عليك على المطلوب اللي يحتاجه يعني.
اوكي، والبروتكشن؟
البرودكشن بيكون إن الباور بيمشي لك بسلاسة مثل ما أنت سويته في الديزاين.
يعني لو ما حطينا بروتكشن وش بيصير؟
يعني بيكون ديفرنت بين الباور الغير المتوقع في المطلوب، هذا اللي فهمته.
اوكي زين، بنجي لهالمفاهيم. انا مو مهم عندي ان تكون المفاهيم اللي عارفينها صحيحة او زين، انا مهم عندي ان اشوف شنو انتم متوقعين، يعني ايش الاختلاف. زين. فاطمة سيد حسين. يعني انا I'm sorry to call names، بس الهدف ان just to see to add any participation doesn't need، يعني مو كل اللي الحين اللي قالوه صح. اوكي بس it's fine.
Yes, doctor.
شو الفرق بين البروتكشن سيستم والكنترول سيستم؟ بمعنى هل يكفي أن نعتمد على الكنترول سيستمز وما في حاجة إلى البروتكشن سيستمز؟ يعني إذا نعرف الفرق بالتالي نقدر نميز أن في حاجة أو ما في حاجة.
أعتقد البروتكشن سيستم نحتاجه إلى الهيوج باور عشان لو صار أي دمج نقدر يعني السيستم نفسه يوقف نفسه.
أوكي، والكنترول؟
الكنترول إحنا نتحكم فيه.
يعني لو عندنا هيوج سيستم ما نحتاج لكنترول؟
أكيد نحتاج إلى كنترول.
اوكي، الكنترول دائما نحتاج اليه سواء هو سمول سيستم ولا لارج سيستم. اوكي، والبروتكشن سيستم بعد نحتاج اليه سواء هو سمول سيستم ولا لارج سيستمز. اوكي، بس شو اللي يميز الشيئين؟ يعني متى تكون والله هاي الشغله هي من اختصاص البروتكشن سيستم وهذه الشغله من اختصاص الكنترول سيستم، وبالتالي
يعتمد
ما
على
يصير
التايم.
سوري امل.
يعتمد على التايم، يعني إذا في شيء ينحل في مدة طويلة نقدر نعالجه بالكنترول سيستم، بس إذا شيء لازم نوقفه الحين يعتمد على البروتكشن سيستم.
ممكن التايم، بس تايم في عندنا control systems also fast acting. اوكي very fast. اوكي بنشوف هنا المعيار على اساسه ان when a protection system intervene يعني يتدخل ومتى. اوكي بشكل عام البروتكشن سيستم always provide first يعني provide allow the control system to act first. اوكي يعني ما يتدخل في امور الكنترول طالما انه is able to control the systems by himself. If not, then the protection function takes action. Okay. Yes, Izzat, any participation?
Yes, doctor. I think control is to state the behavior of the system to avoid, for example, the fault.
We want to avoid fault by the control systems.
Yes.
Okay. And
the power system protection is a way to study the system fault.
study system fault, and
That's what I got. That's what I have.
Okay, so there is still, this is what always I expect in you. There is always a confusion between the control systems and the protection system. The purpose of the control system is to monitor the power systems in general. If it is a control system of the power systems, is monitoring the power system voltage, could be a frequency, it could be monitoring the current flow. I can monitor so many parameters, okay? And its purpose to regulate, to maintain those parameters within a safe limit. Within, let's say, voltage has to be within, let's say, 5 plus or minus 5%, or plus or minus 10%, or it has to be at rated voltage. So the control system try, when the voltage up, try to maybe in the generator, it will like to change the excitation such that the voltage maintained at a specific setting, at the rated values. And similarly, a control system can be used to regulate the frequency at the rated frequency of 50 or 60 hertz, depends on the system. Okay, so if the frequency change, then the control system try to adjust the governor so that it will maintain the frequency at the rated value. So each control system has, you know, speed capability. So if there's some situations where a large disturbance could be a force. It could be a loss of large loads. It could be so many phenomena, we call them, causes a disturbance in the systems. So in occurrence of disturbance, the protection system tries to maintain the voltage, currents, or the frequency within the rated or the set values. If they cannot, then there has to be something done. The control system cannot control it at the specified values, and then the protection function takes place. So there is a timing where we say we allow the protection, the control system to act first to maintain these parameters to the safe limit, within a safe limit, within a safe operating limits. If failed, then protection functions take actions, and this action could be slow or it could be fast, or through protection functions to disconnect generally the faulty equipments. So the protection function is monitoring the system also, but its main purpose to detect disturbance and or abnormal conditions and faulty conditions, and disconnect the faulty equipment as fast as possible. Okay, so that the system integrity continues. يعني بشكل ان تدفق الطاقة تستمر من الجنريشن للconsumers with no يعني blackouts. يعني you don't want to have a fault in one transmission line, you lose all the system. That's not a good system, okay, if you have such situation. And with this course, you'll know how do you detect the faults. How the protection system knows that there is a fault, or this is not a fault. So how do he identify this is a normal conditions or this is a fault conditions? Now, there are different fault detection principles protection system use to identify the fault situations, and that you will learn from this course, inshallah. Any questions related to the main difference? One detects faults, okay, and the session when the control system is not able to maintain the system voltage and frequency at the specified, at the rated values. And once I rated values is the 50 hertz, which is frequency, and if it is
دكتور مسامح.
نعم.
مو طالع لنا الشاشة.
مو طالع شنو؟
مو طالع لنا اللي هو الPDF على الشاشة.
Okay. I'm not sharing with you حاليا. Okay, so this is the beginning, inshallah. So in this chapter, the chapter 1 هي بتعطيكم مقدمة يعني بشكل عام عن protection systems. ففي البداية يعني what we are protecting، شو الأشياء اللي احنا نحميها أساسا؟ هي المكونات الباور systems اللي هي الجنريترز or motors, could be transformer, transmission lines, or cables and so forth. So these are what you are protecting, okay? And now to know what are the control system equipments and what are the protection system equipments. So the control systems can be is done through the generator governor. تعرفون عن generator governor شباب؟ It's like a valve that control the steam intake to the steam turbine, or the gas to the gas turbines, or if it is a water to the hydro turbines. And AVR, which is automatic voltage regulator, it is the one that regulates the excitation to the synchronous machine. So this is the controller that maintains the voltage at the terminal of the generators. So we use a control system, a closed loop system. We compare the voltage at the terminal of the generator and compare it with a setting, and we want this voltage is maintained by changing the excitation of the synchronous generator. We have external fax devices. I assume that you have taken one of the elective course in flexible AC transmission systems or controllers. It could be STATCOM, it could be series compensation devices. So there are different types of fax controllers. We can use tape changers and the transformers to change the transformer ratio so that we maintain the voltage using the tape changer of the transformers. We have control systems that maybe control the power flow in the systems, or they control at what situation you should switch a new generator, at what situation you should switch off a generator from the systems, so that the system becomes reliable, okay, and secured. So, but the main purpose of the control system is to maintain the frequency, the voltage, the power flow within the normal operating limits, within the safe limits, okay? But, and these limits are very small. And you don't think, oh, I have a big, you have, let's say, for voltage, you have within 5, let's say, percent limits. Now, if you reach 10% or higher, there will be a dangerous voltage. You should act something has to be done to overcome this high voltage. Otherwise, there will be a damage, okay, to the equipment. So this is the purpose of the protection system to by using fuses, by using circuit breakers and relays to detect this abnormal conditions and initiate the action to disconnect the faulty components. So its main purpose detects faults and abnormal condition and isolate the faulty equipment from the system so that the system continue its operations, okay? And as I said, what we are protecting these equipments, the power system components in the power systems, as I said, generators, lines, transformer, motors, and we are also trying to maintain system integrity. We want to make systems stable by acting so fast to disconnect the faulty equipment. If your action of the protection function is slow, it might lead to a system blackout. Okay. Have you taken power system 2, the transient stability, Shabab? خدتون transient stability? No. اوكي، هالكورس دائما يكون في سمستر 8 لغرض ان you have finished most of the required courses so you understand these phenomena, and I'm telling you, you don't know what's about power system stability, you don't know about you need to take other courses, so this should be in the last semesters that you are taking this course, so that really you understand the course very well. Okay. Can we design a system our system that will never have a fault, so will never fail? Can we? هل ممكن شباب؟
I think it's impossible.
عفوا.
مستحيل يكون عندنا سيستم بدون فولت دكتور.
ايوه مستحيل. اوكي زين، حتى لو هاي بيكون جدا جدا مكلف، معناته انه لازم اسوي a lot of redundancies. If one fails we have the other, so it is so faults would happen. Now can I predict the occurrence of a fault? انا اقول الفولت ممكن تصير، لكن هل نقدر نتوقع متى بيصير الفولت؟
أكيد نقدر نتوقعها.
أوكي.
إذا كانت في ظروف معينة، يعني مثلا التيار قيمته نفرض قيمته معينة، والظروف المعينة يمكن يصير الفولت في هالزمن، يعني نقدر نتوقعها.
أوكي، لو كان نقدر نتوقع، يعني في أشياء نقدر نتوقعها، في أشياء صعب. لو نقدر نتوقع وجود الفولت، بالتالي أنا ما بحتاج ل protection system، لأن I can disconnect the system before and do a maintenance for it before a fault occurs. هاي بيغنينا عن مشاكل واجد. أوكي. بالتالي لو أحس إن هذا اللاين transmission line there will be a fault after a day or after 1 hour or after half an hour, I would or after 1 month, okay, I would do the preparations so that I check that this line will be disconnected and replace it with another line, so before a fault happens. And I will try to maintain it, see, and this is what challenge. Now, this is a future challenge that the things that you can predict, they will be better, of course. But unfortunately, we cannot predict things because yeah, we have maybe sometimes nature. I can predict there will be a storm, and because of the storms, there could be failures. Okay, but I don't know where that failure could be. I can make the system more secure by reducing load or increasing the generations, or okay, making more redundant. But generally, you cannot predict things. Now, what are the faults that we are protecting? We are trying to detect short circuits in the systems. And the short circuits generally could be line to ground faults. And this is the most general types of fault that can occur. Or it could be a line to line. If it's three-phase systems, fault between line 1 and line 2, or line 1, this represents 8% of faults. It could be double line to ground faults, or it could be three-phase faults. Three-phase faults are the least, but they are the most severe in terms of current magnitude and damage that could cause to the equipment. There are, and these are shunt faults. We have open phase faults, like you give a command, a circuit breaker give a command to, or you give a command to a breaker, try to open it, but two-phase has open, or you try to close a breaker, two phases closed, one stayed open. So like you'll have a system that's operating in two phases. So we call this an open phase condition. Okay. So that's an imbalance situation. It's not a shunt fault, it's an open phase fault. And that's also you want to detect and disconnect the system. If you have broken conductors, or we have also abnormal operating conditions, like the frequency is low or frequency is high. Okay, there is no faults in the systems, but there is an imbalance between load and generations. When the generation is equal to the load, the frequency is maintained constant. But if the load is more than the generation, what would happen to the frequency, Shabab? If the load is more than what you generate, what would happen to the frequency? It will drop, okay, below 50 if you are 50 hertz. And that's why the governor will take action to correct it. The control systems that allow more steam for the steam turbine to generate more power, try to correct this. But if it cannot correct this in a short time, then the protection system will take action, okay, to disconnect load, because you have more loads, so it will disconnect loads from the system to make a balance between load and generation power. You could have over or under voltage situations. Okay, it's not due to a fault. Okay, or it could have a reverse power, like you lost the turbine suddenly, but the generator is still connected to the system, but the turbine that drives is get faulty, the valve closed of the steam, or the flame has get damaged, or the gas intake to the gas turbine is lost. So that you lose the turbine, but the generator is still connected to the system. And that situation, the active power flow will reverse. Instead of power generated to the system, the generator now will absorb power to will act as a motor. And we need to detect this situation by using a reverse power detection, okay? A relay that detects that the power has a reverse. This is not related to the control system, okay? Subsynchronous resonance conditions, stability conditions, is all abnormal conditions, something called power swing conditions. And these are abnormal conditions that also protection system need to detect, so that it takes actions to proper actions. What are causes of these false or abnormal conditions? There are so many causes. One of them is nature, okay? Bird can cause, animals can cause faults. See this animals, why it gets out up there, okay? Nature is like a tree, okay, can grow until it reaches transmission line and creates faults. In a forest, like in 2003, United States had, and Canada had a blackout. Blackout means a large portion of the power system get disconnected. So many consumer, millions of people lost supply because of this. Because of a tree, okay, that hits a transmission line and causes large power loss. And that's why now there is a practice to trim, يقطعون الشجر, okay, so that they don't reach the transmission line. Did we predict this? Okay, so the nature, did you predict this going up? You can do some prevention, but nature can also causes faults. So there are different, this is somebody here who in the forest and logging truck. This is trying to wrap this, يعني يربط هاي الحمولة steel wire. So he throws the steel wire and hits the line there. And so his intention to throw it to the other end, but hits the transmission line, create a short circuit that gets fired. So how do you predict this person is gonna throw this to the transmission line? So sometimes you cannot predict these things, okay? Human errors or pairs or storms. Storms can get damaged and the transmission line will fall, cables will fall on the streets, okay? Other causes could be insulation failure. So this insulation failure is one of the common causes that leads to short circuits, okay? This is one of the transformer failures. So generally, insulation aging, okay, due to long duration, each insulation has a lifetime. And also if you operate the equipment not as specified by the manufacturer, you always overload the equipment, you put it in place where the temperature is higher than the specified temperature, the insulation will get damaged. Or if you operate it always at higher voltages, the insulation will get damaged, okay, and failed. Once insulation get damaged, then you will have short circuits. And that's insulation damage, as you said, it's because temperature rise. I showed you also nature, storms and lightning strikes can also causes faults. Human errors could be sometimes human errors on setting a relay will not detect a fault, or human error when he maintained an equipment, he lost a spanner or a piece that created a short circuit after the maintenance guy leave the site and try to open the switch on the circuit, they create a short circuit. What are the consequences of those faults if you have not detected? Okay, it is a high loss. Okay, it causes fire, loss of equipments, loss of revenue, because there is a failure in the equipment. You need to replace it. Also, you need to loss of supply to the consumers. So that's so this is like damage in generator and turbine together. Okay, big loss if you there is a damage in a generator with the turbine. There is a video here that shows, I don't know if it's shown in the blackboard. So this is a failure in the transformer. I can see the video, inshallah. It's a transformer. Okay. So there's a transformer failure, and after these failures, it causes an explosion. So not detecting a fault also can cause an explosion that not damaging only the transformer, also will damage the surrounding. Okay. During faults, there is a distinct an increase. For the short circuit, the current will increase to very high values compared to the normal load currents. And sometimes can go to 20, 30 times this, this value. And maybe this is a criteria based on which we can detect short circuit. We monitor the current's values. The voltage in some situation during shunt faults, normally it will decrease. Okay. So if the voltage persisted low, this is also not good for the systems. Okay, we'll come to this later, inshallah. What are the consequences of faults? In generally, long duration of short circuit. If it's not disconnected, it will damage the power equipment. It will lead to a supply interruption, of course, loss of revenue due to loss of equipment and disconnection of supply from consumers, loss of stability, and reduced voltage over nearby systems close to the area where the fault is located. And What action we can take, Shabab? There are so many actions. And it depends on the situation. And mostly we would like to isolate the fault by opening circuit breakers. Sometimes we open only one circuit breaker, sometimes we open two circuit breakers, sometimes we open more than two circuit breakers to disconnect the faults. Okay, we'll come to this, inshallah. Sometimes the action is not immediately taken. It takes a time delay first. I wait before I take action. Sometimes I take it immediately. Sometimes I give an alarm if the parameters is not too high. Okay, I give an alarm that there is indication. This is not an urgent, but it will give an alarm that there's an abnormal situation that needs to be taken care of before it evolved to a dangerous situation. Sometimes a relay switch on a capacitor or a reactor to regulate a voltage. Okay, but in that situation, a relay is not now a protective relay. We call it a regulating relay. Okay, or sometimes we disconnect load, and this is load shedding relays. Okay. Sometimes we don't take any actions, although we know there's an abnormal conditions, and this happens when we detect a power swing situations. A power swing is when you have a sudden loss of generation or sudden loss of load, the synchronous machine will oscillate with each other, okay, and create a power swing that looks like a fault from the relay perspective, but this is not a fault. And this oscillation will decay with time, but the relay should identify this as a power swing, as not as a fault or a short circuit. The building components of a protection systems is these. These are the protection system normally require information first. Yani how a relay or a protection system know there is a fault. So it needs sensing devices, no? So it needs sometimes a current and a voltage or both, okay, to know the current situation of the system, to know if there is a normal situation or this is abnormal situation. Now we need, that's why we need a current transformer and a voltage transformer as inputs that step down the current, high current, to a lower current, to a standard value, and this voltage transformer will reduce the voltage to a lower voltage, okay, a standard voltage. Normally the voltage here, this could be a 400 kV, but this is 110 to 120 volt at rated voltage. Similarly, this could be 1000 ampere here, the rated current of the line. We reduce it from 1000 to 5 or 1 ampere here. So these are the current and transformer. Their purpose to provide two things. They step down current and voltage to a standard values suitable for the protective relays. And the second objective to make a galvanic isolation, to isolate the high voltage system from the protection system. Okay, so they have two purposes. And the relay here is the piece of equipment that based on these two information, it knows this is a normal situation or there is a fault conditions. Now, if this is a fault condition, it will give a command to this breaker, circuit breaker, to open the circuit. And as well as sometimes will send a signal to other breakers also to open if there are the requirement. And sometimes it's inform other relays that they should act, or they inform other relays that they have found a false. Okay. Sometimes they give an alarm. Okay. So relays does not just rely on current as input voltage. Sometimes it needs also GPS signal for synchronization of the voltage or current received here with the current received from other ends sometimes. So these are the components of a protection system. Now, circuit breaker and high voltage system is different components than a relay or a protective device. Okay, and low voltage systems, you don't have relays, or what you have a circuit breaker. You don't have CT current and voltage transformer. The circuit breaker and the protection functions are integrated together in one device. Okay, so here we are not talking about protective devices in our houses, okay, where a circuit breaker has the protection system and it does the disconnection as one device. The circuit breaker here is purpose to it is a piece of mechanical switch, okay, device is used to has the capability to disconnect short circuit, okay, and disconnect short circuit. Also, it can be used to switch on or switch off this circuit, the protected circuit. So we have this circuit breaker should have a breaking capacity, current breaking capacity that exceed the short circuit current. Yani, if the breaking capacity of this less than the short circuit maximum short circuit current, this circuit breaker will get damaged also. So we need to know how do you select a circuit breaker that is capable of disconnecting this high short circuit current without being damaged. Okay. So you know there's one chapter on circuit breakers. So we'll have one chapter on the relays. What type of relays are there? We have one chapters on current transformer selection and voltage transformer selections. We have so many chapters on the detection principles, how these relay detects that there is faults. Any questions so far? Okay. So this is just what I have explained and the importance of circuit breakers. Normally, interrupting capacity of circuit breaker are expressed nowadays in kiloampere. It's not in MVA now. MVA was a previous practice, but nowadays it's in kiloampere is we call it the interrupting capacity of a circuit breaker. Now, current and voltage transformers in high voltage system is not different than low voltage systems. And in high voltage systems, it looks like this is an outdoor substations where we have, this is the circuit breaker. This is like Y shape. This is a circuit breaker, okay? This is one end, this is for one phase, second phase, three phase, third phase, okay? Now this, we have also, this is a current transformers here, okay? You have voltage transformers. So inshallah in this course, you know why they looks like this when we cover the next chapter. We might need also a communication channel to transfer this information to the other relays at the other substations. Like in transmission line that has, let's say, 100 kilometers, one relay at one side, the other relay 100 kilometers away. So you need to transmit this information to the other end, okay, that this relay has detected a fault. So the other relay knows that this is this situation. And to transfer this, you need a communication media, okay? So the communication media here could be, we could use the transmission line as a communication media, and this is called power line carrier, okay? We can use fiber optics as a communication media, okay? And we'll come to this, inshallah, how the protection relay make use of the communications to make better decisions and faster decisions if the relays or protective devices share informations through the communication system. So what's a protective relays is a piece of equipment. Its function is to detects a protective relay, a piece of equipment, its purpose to detect defective or abnormal system conditions. So its purpose that detects there is a false or abnormal conditions. Now it has response. What its response? It trips a circuit breaker to clear that fault. Okay, and we have some situation at abnormal condition we close a breaker sometimes if it is not a protective relay but a regulating relay. Okay, in some cases issue alarms, as I mentioned before. We don't trip a breaker, but we issue alarm. So generally, this equipment is a reactionary device. It does not predict that there will be a fault. Okay, and we take actions. How fast it detects a fault and clear that faults now it depends on the technology. Okay. Now relays detects a fault based on either local measurements, like in here, like we are in a substation, and this is a local measurements, or based on information received from the other side, from other relays. So they call it a remote end. So we can use a local or information received through the communication channel, so that we identify if there is an abnormal or if there is a fault conditions. Then decisions, if this is abnormal or a short circuit, for example, and it is in the area that this relay is responsible for, then it will take a trip action within 1 to 3 cycles. Okay, yani nowadays relays in transmission systems is very fast. One cycle means 20 milliseconds. We have relays that is working in 3 milliseconds, very fast relays. Okay, and their working principles is based on traveling waves. Okay, they are very, very fast, and after they detect that there is a fault within, let's say, 1 cycle time, they give a command to a circuit breaker to trip. And this circuit breaker, they are mechanical device. They take time to open their contacts. So they take sometimes 2 to 10 cycles, depending on the type of the circuit breakers. Now, what are the detection principle? How to detect that there is a fault or this is a normal conditions? There are different detection criteria. One of them is a current. I can use a current as a criteria. At normal current, the current is up to full load values current, but If the current exceed the full load currents, then there's abnormal conditions. This could be due to short circuit, and we can take action based on this. So we use the current as a criteria to detect faults. Sometimes we use difference in currents, okay, to detect faults. Sometimes we take a phase angle difference to detect faults. Sometimes take the voltage magnitude. If the voltage exceeds 110% of the rated voltage, this is an over voltage, and if this persisted for this duration of time, then we take action. This is an over voltage protection. Or the voltage is below 90% of the rated voltage. That's an under voltage situation. We can take action. We detect the reverse power, like as I mentioned before. So we measure the power and see if the power direction has reversed. We can detect fault based on the symmetrical components. تعرفون واش معنات symmetrical components شباب؟ Symmetrical components. Yes, no. معاي انتون؟
Transfer unbalanced to balance.
Yeah, symmetrical component اللي هو البوزيتيف والنيجاتيف والزيرو sequence, okay, components. These are the symmetrical components. So we can detect faults. يعني during normal operating conditions شنو what is the value of the zero sequence and negative sequence components في الوضع الطبيعي إذا ما عندنا أي faults. شنو بتكون القيم للبوزيتيف للنيجاتيف والزيرو sequence؟ They are zero. We don't have such components. Okay, if the system is totally balanced. Okay, so when you have a negative sequence current or a zero sequence current, and indicates there is a fault, okay, or unbalanced condition, and we can use it to detect faults. Inshallah, this is I'll also show you this. How do you use the symmetrical components to detect faults in the motor protection chapter? We can use the impedance as a criteria to detect faults. Like this is the principle used in distance protection. We measure the impedance during faults, and we compare it with the normal impedance of the transmission line. If it is lower, then there is a fault. If it is higher, there is a fault not in the line, okay? Or it could be a normal operating conditions. We could use the frequency, the change in frequency from 50 hertz, okay? Based on this change in frequency from 50 hertz or 60 hertz, I can detect there is an abnormal conditions. There is imbalance between generation and loads, and we need to take action. Or sometimes we use the rate of change of frequency with respect to time for load shedding. There are other criteria which is not based on electrical quantities, like we can use the oil or the gas rate in the oil tank of a transformer. This principle is called Bachel's relays. We could use the pressure. We could use the, sometimes we use harmonics. The presence of second harmonics. Okay, and during normal operating conditions, we don't have harmonics, but if the second harmonic is too high, that has indication of the fifth harmonic is high, this has an indications of something, okay, a phenomenon. So sometimes we use harmonic to detect abnormal conditions. So this is an example. I will conclude with this. This is an example of a protection system of a transmission line. At each end, this end could be 100 kilometers away from the other end. Okay, so when there is a fault in the transmission line, there is one relay now at this end, there's another relay at the other end, and between them could be a communication channel. Okay, they can work also with without communication, but generally transmission lines, they have a communication channels in between. Now, if a fault happens here, now the current in the line will increase, okay, and this relay normally will measure the impedance from this end to the fault point, and will compare it with the impedance of the line. Now, because the impedance now has reduced because of this fault, this relay will give a command to this circuit breaker. It will open the fault from this side. So there will be no current flowing from this side once a breaker 1 is open. However, there will be also a current fed from the other end. So this fault is not cleared unless the other breaker is opened. So this relay, once it gives a command to this breaker, it will send through the communication channel a command to the other relay telling him, I have already issued a trip signal to my breaker, and I will recommend you to disconnect your line, even if you did not discover this fault. So this relay will, once it's received this command from the other relay, it will send a command to this breaker to open breaker 2. And with this line this fault is disconnected from the two ends. So this is a protection system, okay, for a transmission line using a protective relay, current and voltage transformer, circuit breaker, communication channel, all together in that system. But not all systems would require communication channels. Not all system protection require both voltage and current. Sometimes you need just a current as input. Okay. So this is the end. Do you have any questions, Shabab? No questions?
Doctor,
okay. Yes.
Regarding Blackboard, I think there are some issue file or Blackboard. I don't know. I cannot already download the syllabus or recorded video. I don't know what there's problem.
You cannot download that one also?
Yeah, syllabus also.
Syllabus, okay. I just downloaded the syllabus from here. Maybe you have problem with your browser.
I don't. I will.
I don't.
Try it to other PC or something.
ايه اوكي الباقيين قدروا ينزلون السيلبس فور اكزامبل شباب؟ هل عندكم نفس المشكله؟
انا نزلت دكتور شيء تمام
ينزل عندكم اوكي. فيعني ديبنز انا يعني مثلا عندي التاب ما قاعد ينزل الوورد، يقول لي انه اتس نوت افيلبل، زين، بس على الكمبيوتر هاي اللي قاعد اشتغل عليه انه ينزل. ف depends on the settings. طبعا ساعات الاوفيس not updated او زين، او في missing link او براوزر في مشكله في السيتنجز. ف in this also chapter I have added here why do we need a protection system. يعني في هني additional slides اللي تفتح لكم هاي why do you need a protection. يعني شنو مشكلة لو يكون عندنا under voltage؟ قصدي لو صار over voltage شنو مشكلة الأوفر voltage؟ ليش نحتاج نحمي السيستم ضد الاوفر عشان لو صار over voltage I want to take action. What happens if you do take any action if the voltage exceeded 110% of the ليش احنا ناخذ اكشن لما يكون عندنا under voltage؟ يعني over voltage فهمنا ان الفولتج عالي لكن الفولتج ينخفض عن 90% من الريتد، ليش نبغي ناخذ اكشن؟ اوكي، وهذه يعني ليش الاوفر كرنت خطير وبالتالي لازم ناخذ اكشن؟ ليش الاوفرلود مشكله يعني لازم ناخذ اكشن؟ ليش الامبلانس مشكله ولازم ناخذ اكشن؟ زين، ليش الفريكونسي يعني بتسبب مشكله؟ الاختلاف عن 50 هرتز او 60 هرتز سبب لنا مشكله ولازم ناخذ اكشن. اوكي، ليش اللوس اوف synchronization عندنا مشكله ولازم نكتشف ان there is a loss of synchronism ولازم ناخذ اكشن. هاي summarize the problems. اوكي، بالتالي خطوره problems on the system so that the protection function should detect those situations and يعني reduce the damage. ساعات احنا we don't ساعات prevent the damage but we reduce the damage. اوكي شباب، I will stop here. Stop recording. We'll meet inshallah next class to